multiply, or divide. So figure out what the answers are for 1 through 6. What do you notice about these two boxes? How many cans of soda can they hold? If both boxes can hold 12 cans of soda, which one do you think has a smaller surface area? Which box would require less material? Why do you think that would be important to a soda company? Here we see the dimensions of these boxes. Let's calculate the surface area of each box. So for this one, we have the top and the bottom, the left and the right side, and the front and the back. The top would be 7.8 by 10.5, and the bottom would be the same size. The bottom is the same, 81.9. The left side is a 5 by 7.8 rectangle. And the right is the same size. And the front is 5 by 10.5. And the back matches. Which is 52.5 for both of those. To find the surface area, we add up all of the faces. So 81.9 plus 81.9, and then we need 39 and 39, and 52.5 and 52.5. For this one, we also have a top, a bottom, a left, a right, a front, and a back. For the top, it is 15.8 wide and 5.2. The bottom is the same. The left side is 5.2 and 5 tall. And the right side is the same. The front is 5 tall and 15.8 across, which is 79. And to find the surface area, we need to add all of those together. So 8216 plus 8216 plus 26 plus 26 plus 79 plus 79 is 374.32 inches squared. So this one requires less surface area or less material to make. So perhaps the company is going to choose this setup because it's cheaper. You don't need as much material. But maybe they're going to choose this setup because it doesn't take as much space on the bottom. If we look at the bottom here, so the shelving space, actually that one takes up more. So this one might be better because of the shelving space requires less. In 1998, a soda company researched customer habits and discovered a problem with the design of its 12-pack box. The company found that many customers opened the box, unloaded several cans into their refrigerator, and stored the box with the rest of the cans in the cabinet. When the customers were thirsty and no cold cans of soda were left in the refrigerator, customers would not return to the box in the cabinet. Customers would choose a different drink instead. So in 2002, the soda company made a simple change for the design of the 12-pack box. The 4 by 3 by 1 arrangement of cans that had been used for more than 20 years was replaced by this new 6 cans by 2 cans by 1 arrangement. Customers liked the new shape of the box because it was easier to carry and it fit nicely into their refrigerators. So perhaps that's why they go with the long, skinny box. Because customers could store the box in the refrigerator, they finished all the cans of soda sooner than they would have finished all the cans of soda in the old box. This caused customers to buy more soda. In addition, the new box was still affordable for the company to make, even though it required slightly more cardboard than the old box. As a result of the new box, the company reported a substantial increase in sales. So the amount that they were paying extra for this new box shape was made up by their increase in sales. What do you think a company has to consider when designing a package for a product? Here we have an ice cream sandwich. Your task: design a box in the shape of a right rectangular prism to hold 12 identical ice cream sandwiches. Make a poster. Be sure the poster includes each requirement listed in the task guidelines. Task guidelines. Determine 3 different arrangement options for 12 ice cream sandwiches. Sandwiches must be placed in the box with the same side down. Describe each arrangement option. Include which side of the ice cream sandwich is down, and include the number of rows, the number of ice cream sandwiches in one row, and the number of ice cream sandwiches stacked. Draw a diagram of a box for each arrangement option. Label each diagram with the following: the length of the box in inches and the number of ice cream sandwiches along the box's length. The width of the box in inches and the number of ice cream sandwiches along the box width. The height of the box in inches and the number of ice cream sandwiches along the box's height. Calculate the surface area of each box in square inches. Choose one of the 3 as your final box design and justify your reasoning. Be prepared to report your choice and reasoning for the final box design to the class. Here are the dimensions for your ice cream sandwiches. Here is one possible option. Is to describe the arrangement. So this has the flat side down. You can see my ice cream layers between my 2 cookies. And then it also says to include the rows. So I have 3 rows of 2, and it is stacked 2 high. Three times 2 is 6. 6 times 2 is 12. So I have all 12 ice cream sandwiches. Then it says to label the length, the width, and the height. Well, these are 4.75 inches long and 1.5 inches wide, and they are 0.75 tall. So if it's 2.75s, 0.75 plus 0.75 is a height of 1.5 inches from 2 sandwiches. If it's 1.5, 2 1.5s makes 3 inches, and it is 2 sandwiches wide. And then I have 3 4.75s. So I can multiply 0.75 times 4.75 times 3, which is 14.25 inches and 3 sandwiches wide. We are also asked to calculate the surface area. So we have a front and a back, a left and a right, a top and a bottom. The front is 14.25 by 1.5. The left and right side are 3 inches by 1.5. And the top is 14.25 by 3. So to start off, 14.25 times 1.5 is 21.375. 3 times 1.5 is 4.5. And 14.25 times 3 is 42.75. To find the whole surface area, we need to add all of the faces together. And that comes out to 137.25 inches squared. Now let's consider another arrangement. Here I have option 2. This is 1, 2, 3, 4, 5, 6 rows. Of 1 bar in each row, and they are stacked 2 high. So 6 times 1 is 6, times 2 is 12. So in this we have 1, 2, 3, 4, 5, 6 bars or sandwiches. This way we have 1 bar or 1 sandwich, and this way we have 2 bars or sandwiches, ice cream bars. These are also laying on the flat side down. Remember, the flat side is 4.75 across, and there are 6 of them. So 4.75 times 6 will tell us how far across the bottom, and that is 28.5 inches. One bar wide is 1.5 inches. And 2 bars tall, remember they were each 0.75 tall. So we have 2 of them, that is 1.5 inches tall in that direction as well. Now to calculate the surface area, we have the front and back, the top and the bottom, the left and the right side. The front is 28.5 by 1.5. The top is 28.5 by 1.5. So that's the same. And then the bottom is also going to be the same. And then the left and right side are 1.5 by 1.5. So 28.5 times 1.5 is 42.75. One and a half times 1.5 is 2.25. So to find the surface area, we will add all of these up. And that should be a surface area of 175.5 inches squared. Here we have option 3. Actually, we're going to make option 3 look like this because I already had a 2 by 3. All right, so we have 4 bars by 1 bar by 3 bars. Now we need to figure out the inches. We also need to state how these are oriented. And these are arranged with the short side down. We would say there are 4 rows of 1, and it is stacked 3 tall. So each of these is 0.75. So 0.75 times 4 is 3 inches. And then this direction is 1.5, and there's only 1. So that is 1.5 inches. And then each of these is 4.75. And there are 3 of them, so that is 14.25 inches. For the surface area, again, front, back, left and right, top and bottom. The front is 3 by 14.25. The right and left side is 1.5 by 14.25. And the top is 3 by 1.5. So 3 times 14.25 is 42.75. 1.5 times 14.25 is 21.375. And then 3 times 1.5 is 4.5. To find the total surface area, we need to add all of these together. Which is 137.25. Then we need to decide on a final design. I think I like this one best because it's a tall, narrow box. And here it says the cost of cardboard is $0.0004 per square inch. Calculate the cost of the cardboard needed to make one box in each of the 3 designs. So to do that, we're going to take the total surface area from each of the three options, and we're going to multiply by how much each square inch cost. So for this first one in option 1, it is 0.0549. So that's approximately 5 cents. For the second one, it is 0.0702, or approximately 7 cents. And option 3, we had the same surface area, so we should have the same price. Our next bullet point says determine the total cost to make 1,000,000 boxes of each of these designs. If we're going to use 1,000,000, we don't want to round and have what's called round off error. So we're going to go back to the whole decimal and multiply by 1,000,000. And that should be 549. So 54,900. For this one, we're going to go back to the original and multiply by 1,000,000, not 10 million. And that is $70,200. And for option 3, it should be the same as option 1. The next two bullet points are asking us the difference in the amounts. So we have, for one box, 7 cents minus 5 cents is a difference of only 2 cents per box. However, when we look at it in the 1,000,000 boxes, when you purchase 1,000,000 boxes, the difference between the two different arrangements is $15,300, which is a lot of money when you are buying a ton of boxes. And typically, companies that are making products are going to make a bunch of those products to ship out to various stores across the nation. So that is all for lesson 14 on designing a box and thinking about the surface area and how much it costs to make those.